Colleagues, as then said, I would like to call the next three speakers in consequence, and we can now let the last row. If you wish to go powder your nose and have coffee, but I'd like to call to the stage Mr. Percy van Staden. Now you would have seen that he's talking about a hybrid model, which is getting more and more exciting. So Percy, welcome.
Thank you. Ja, ek weet nie, is almal nog mooi wakker. Ek dink daarom dokter het almal wakker gekry. Ek hoop ek gaan hulle nou nie weer aan die slaap praat nie. Maar baie dankie vir die geleentheid. Thank you very much for the opportunity to share with you what as an entrepreneur we have done up until now, and the group of people that I'm with in Renatus, and the decisions that we made on how and what we will try to achieve in contributing to the solution of this energy crisis that we are dealing with. My background, I was a lawyer, I was still a lawyer, then more focused on management, started at Stellenbosch, and then after that started to get more interested into the energy thing that we're dealing with. And my teachers always told me at school I need to become an engineer. And maybe they were right, so that's what I'm studying now. And I'm enjoying that to a large extent, because there's a lot of new technologies in that, like we've heard today. What is the choices that we need to make as entrepreneurs to really contribute to find a solution that we can fund, one that is financially viable, and one that can contribute to the microeconomy of the area, and in the same way contribute to the larger economy of our country, and then also to the aims of the world, as we see people in the world today with COVID that taught us quite a lot of lessons. Professor Schwab, I read his book recently, head of the Financial Forum. He said that we learned a lot from COVID. That's good. It's not all bad. And I think that is maybe one of the main reasons. I can't read there, but I'd like to read you this, what was said by a physician many years back. And yeah, that was what Max Planck said. And he was the father of, or considered the father of quantum technologies. He said, a new scientific truth does not triumph by convincing its opponents and making them see the light, but rather because its opponents eventually die and a new generation grows up that is familiar with it. So probably, Dr. Kim, that's going to happen to the energy sources that you have in mind. But and I appreciate that we cannot today decide we're going to throw anything out by the door. We need to look at everything, and as entrepreneurial approach we had to this in property development, we had to say, but what do we need? And so the resources, the technology, that is the first thing. We needed to look at suitable land, and we had a discussion about zonings, and I'll deal with it a little bit. We need knowledge and skills, development and training. Yes, we do have it in South Africa. We have a lot of knowledge and skills in various communities, not only the Afrikaner community, and it's a fantastic opportunity that's been given to us today to be together and to say what can we offer and how can we enhance the skills that we have. But there's a lot of skills overseas that we can learn from. There's a lot of mistakes we can learn from, like we've heard today as well. And then I'd quickly like to share with you a bit about the sustainable markets and the finance. And Chris, yes, I did fly in this jacket. My wife brought it for me. I forgot it at home. So that's in the environment we operate. We don't wear ties, and we take our hands out and we start working together, and we find solutions together with the people on the ground. Because you want your business to succeed and you want people to buy in. And one of the major things that's very important, and that's not on that list of mine, and that's people. People, communities, the involvement of communities, the acceptance of what you offer. I don't know whether I will go camp next door to a nuclear facility, but definitely not next to a coal producing facility. And I've been in coal for a while in my life. I don't think I will do that. Batteries as well, I have something to share with you on batteries. I think, yes, I agree, those batteries that explode like you've shown, I wouldn't go there. But I think there's technology development in batteries that I'd like to share with you today. So, yes, that's the things then that we, resources and technology, that we looked at, and Chris, very much the same. I was surprised to hear this about the ammonia. And why would we focus on ammonia production as entrepreneurs? It made sense to us to add a product that we can sell, a product that we can export, a product that makes sense, that will bring income to the community. We also have a model in our developments where we set up a non-profit company where we have a percentage of the income of the products produced that goes to the community development, and it does not go away from that area. It stays in that micro economy, and then when it earns income, it brings more income into that community. And it creates still the opportunity for entrepreneur to be profitable, to make money out of what you are doing, and to award your own efforts. But your own efforts get awarded not above what is needed. It's getting awarded properly for the effort that you're putting in. So we identified the different things that we needed was to say, so are we going to do solar harvesting? That was one of the things that was important to us. We needed suitable farmland where we could do the farm voltaic way of getting the solar power, and we needed to look at storage. Very important, because there's just no base power if you don't have storage, and you have to have proper storage. And it's very interesting to hear about the nuclear and all of that. I don't know how affordable it will be for us in projects that we do. I don't know exactly. Maybe you need a bigger group of people that buy into that. I don't know. I cannot comment on whether it's how safe it is or not. I accept what you are saying about it. And maybe it's just a matter of living with it and get away from all the negatives up until now that we've heard, and to really look at the facts. But for solar, it's proven enough that we said we'd go for that. But so we needed nitrogen and we needed hydrogen to develop it. And in South Africa, I engaged a company, a South African guy, again, that has a hydrogen production plant that they have patented, and that can produce hydrogen at a price range. If your solar generation per kilowatt hour is less than R1, or even R1.30, they'll survive, but R1, then they can produce at $3.50 a kilogram of hydrogen, which is good in terms of the world demand for hydrogen and the price, the green price for hydrogen per kilogram. And they can do it with less power in the process, and that's how the price comes down. So then we needed to produce that, and I'm going to share with you some of these technologies just to show you that it is there. Because I had to put this together to get funding. If I can't show to the banks, and Chris, yes, I had them too, because they say no, and they're naysayers, because they want to see. And it's right. They don't want to see 30 years and that, because it's going to change again. So they're not going to invest in a battery that's going to be discontinued in the next 3 years, 4 years. Maybe there's new technology. But if the battery is such that you can recover all your income and all your money that you've spent on, all the capital at least, then the bank, well, they find it very attractive. And that's why we opted for the vanadium, and that the name vanadis is what we use, because vanadium flow batteries is the batteries that we look at. So I'll share with you that. And then syngas compressing, and then we have NH3. So if we have all of that, we could take a piece of farmland, and we can develop it in a way that it is profitable, with an additional income stream with the ammonia, with an export possibility of the ammonia. So agri-PV. I don't know, I've taken a few pictures from the website of the party that we have engaged as our partner to assist us, and I've had discussions with them, so they're very happy that we do share this. I'm not going to go into the detail on the slides. The slides will be available and will be made available to you so you can have a look at it, but we're working with Bioware, and that's typical what a farm could look like. And look at that one, for instance, and I'm just going to speak to the pictures at the moment. So Sheep farming is possible with agrivoltaic. You can have it properly planned, and in Europe, what I understood from our partners Bayware is that they had to test various ways of deploying the agrivoltaic. You need sunlight for cultivars that you have underneath, like apples and pears and all of that. And they've tested it to such an extent that the different models that they apply is leaving space for airflow, leaving space for sunlight, and in some cases like that. You'll see in the picture there, and that's a very interesting picture to me, that is where we have a piece of land that we're busy with in Gauteng between Johannesburg and Pretoria, close to the airport. That piece of land is on the urban edge. So now if we have to, from the lawyer side of me, I got involved in all the legal stuff as well. So now we need to get that land zoned, and it's on the urban edge. And what do we need? We need much more than only deploying agrivoltaic PV. We need a space where we can deploy the battery. We need a space where we can deploy the manufacturing of ammonia. Ammonia is poisonous. That's only the one thing that you need to contain, but so is petrol, so is diesel, so it's poisonous. So you need to have a sort of an industrial site that's also part of farmland currently. And that's one of the major problems that we have, is that we need to define what is an agrivoltaic farm, a community or a community development, so that there's a space, and maybe even a space to put your production that will come out of it. And so more industrial, like make the people that live on the farm industrious, but also give the people that live on the farm tenure, land tenure in a way, that they sure they have, even if it's just an occupation right for life or a lifelong right, but then at least the person that works on the farm can have a place that he can stay. So it means you need to have to develop this in a way where you look at all these aspects, and you need to address all these legal stuff. But there the councils can play a massive role and bring in maybe the piece of land where you're going to, especially when you're on the urban edge. When you're out of the urban edge, away from that, all of it will be off-the-grid services. We have all kinds of off-the-grid services now available for sewer systems, for water systems, for all of that. And all of this whole development that I'll show you at the end a picture of, it has all off-the-grid. But still, kids need to go to school. Kids, you need to have clinics, you need to have access, you need to have transport to that. A battery-driven taxi makes a lot of sense to us. So we look at mini-grids, mini sort of microeconomic development, and a agri-farm and upliftment of communities, and to create an ownership opportunity for them. That picture that I wanted to show there was they use wood. And the structures that you use to put up the solar is also used in the farming concept. So you've got a bit of a sharing of cost. That makes it more feasible in deploying this in your farming environment. What has happened there? So that's basically the pictures of that. I'm just going to go through that. And then I did mention, and I know we are a bit limited for time, but Bayware, they have engaged with us for Southern Africa, and they will partner with us to deploy their product. And then they bring the specialists. They train the specialists in our environment, and that's one of the major things that's to us very important. We have identified quite a few pieces of land on different places where we want to develop these agrivoltaic farms, but we want to link them in to the local schools and to a school that oversee the process, that it can be used as training facilities as well for the youth to be involved in this, and it can actually uplift your schooling of people in bringing these products to fruition. So that battery is the vanadium flow battery currently under construction, and that is only a picture of that. And I'm not only going to show you a picture of a vanadium battery that is under construction, but I will also show you a real one that's been built. So the vanadium flow battery, those are the claims that's made in terms of what is the risks involved. with that battery opposed to all the other battery systems that we have. And we can share the detail of that if someone is interested in that. I'm not going to go into that. But one thing that's really important, and I want to share with you, is that the vanadium flow battery was the first battery that the fire regulatory in United States of America approved straight away, because it won't explode, it won't take fire. It is an electrochemical process that we're dealing with, and it's not a chemical process, and most of the other batteries has this problem that it builds up the history and that it has a problem with the voltage and it ends up in exploding. So this is a real one that's been built, operational, and maybe that can be seen as the one that is the one that gave birth to the technology. It runs, it is successfully deployed, and more of that is deployed in America. There are certain states in America that's focused to deploy these type of batteries. One problem with vanadium, it's a very expensive product. You pay about $18,000 per ton of vanadium. But the interesting thing about South Africans is that they have a plan. Now, I've heard that twice now, 'n boer maak 'n plan, maar die ouetjie wat dit vir my gesê het, hy was 'n Joodse ouetjie, hy sê vir my 'n Jood maak 'n plan wat werk. Maar I don't want to go into that. But the boer maak 'n plan, and this is a South African, and in South African context, there's a plan. The mine has decided to mine primarily vanadium, whereas in the past, vanadium is only a sub-product in the mining environment, and then the steel industry would pick it up, all of it. They will just buy it up because they need it to strengthen steel. But the current mine, they mine primarily vanadium to put it into vanadium batteries, and they don't sell the battery. They rent the battery to you, and we still get our price in terms of the PV and the battery per kilowatt hour under R1.30. So it means it is under the price that Eskom is selling to most of the councils and everyone. So that is the major reason why as we chose that as an opportunity to pursue. But now, if you do a vanadium battery, it has to be big enough. And if you do an agrivoltaic farm, the power that you're going to generate is about 50 megawatt at least. And you're not going to, it's 0.86 megawatt per hectare that you will generate with these agrivoltaic PV. But now you need to store that, and you need to do something with the power. And one of the major things that was said to us by our partners who's prepared to bring the technology to help us fund it and everything was, guys, we don't want to sell to the grid. We're not going to get paid. And I think that is one of the things that the councils can definitely look at, and because it is a problem. You can't get funding for the grid because people have this absolute belief they are not going to be paid. And for that reason, they won't give you funding. So we needed to come up with something else as entrepreneurs on, okay, but sure, okay, we have an off-take agreement, and yes, we will not be paid by the councils. But then if they don't pay us, we don't give them power, and then we just sell the power in a different way. Okay, but then the law is against us. We can't sell it to anyone. So we can generate ammonia, and we can sell it and can have an off-take agreement on ammonia. And in our own scenario in South Africa, we are a net importer of ammonia. And Chris shared with you the price of ammonia currently. So ammonia is a great product to generate from these type of developments, and it gives you the second option of an income stream to repay the capital that you have to spend on building these things. So where do we get the nitrogen? If you drive towards Witbank area in Mpumalanga, you'll see there's a facility like that, and the people are generating medical oxygen. But it's more or less the same technology. The technology exists. This is what it looks like, more or less, and they grab that from the air, and if I'm not mistaken, it's about 70% nitrogen anyway in the air that we breathe. I think it's more or less that. So nitrogen, there's a facility that you can do that. Then I shared that picture That is not the full picture of what a electrolyzer look like that has been built in Centurion. It is there. It's patented, South African product. I mentioned that when we started, and that product is part of the solution of getting the hydrogen. Now, then you need a syngas compressor. Those exist, and I've just shown you that picture with the red underneath. You've got all these other ways of getting to nitrogen and hydrogen, but we get to it in a green way. We use solar. We power the system that grabs the nitrogen with solar. We power the system that gives the hydrogen with solar through the battery. We produce enough solar during daytime when we have power to store in the battery, and then also to produce enough nitrogen and hydrogen that during nighttime, the plant that produces the ammonia runs at 30%. So it has enough storage for that kind of product, and it runs through that. So then the next thing that happens, there's one. So Capson is the other technology partner that we have engaged. And I should mention at this stage that we also have a partner in Germany and also in Switzerland. And this partner of ours has now come up with an even better product that Capson can offer us. They have a running system that is successful in China and in India that you can actually go and have a look at. And again, we stick to this one because this is the one we can go show the bank. The one in Germany, once it's done, we will swap to that technology once it's proven that it's more cost efficient. So that is what happens. It's an absolutely 100% green product. I asked about the electric cars because I'm a believer in hydrogen fuel cell cars, much more than battery cars. This type of microgrid technologies that we have can create right across the country in the farming communities enough hydrogen to start putting up hydrogen fuel cell cars refueling. And especially in the trucking environment, we have a trucking business. I see my two sons are here. One of them is managing that. I've been asking him for a while, we must just get rid of all these diesel trucks, because I hear we're going to have a big problem with diesel in the very near future. But be that as it may, I think there's in this model an opportunity to charge battery cars and to charge hydrogen fuel cell cars. And if you position it right, you can do that. Why would I say also battery cars is that you have solar power going into a battery that's direct current into a battery that will deliver direct current, and that will give you quick charges to the car because the car needs direct current as a quick charging into its battery. So the versatility of this solution is that it gives you the farming opportunity, it gives you the food security produce that you can do. And in South Africa, water is some of our maybe biggest problems that we need to deal with. In Europe, it is the area of land that they need to deal with. And that's why they had this focused units where they have agri farming underneath of the solar generation. The water factor is managed much better under the facilities and under these panels than if it's an open field that we are dealing with. So that is the reasons why we did that. So intensive farming is possible, and intensive farming, especially on the urban edges where we focus at the moment, and we can see the markets are there. Solar power harvesting, we can do that. And then we have this localized tenure that we are now negotiating with the authorities to give us that opportunity to give localized tenure to the occupants that works for us. And then production of valuable products. So I just want to go a bit to ammonia again. So ammonia is NH3. It means that you have 3 hydrogen molecules that is now no longer so volatile than it would have been if it was on its own under pressure of 700 bar. It means you can now move it around. In the world, 200 million tons of ammonia is currently being moved around. So you have a network that's already distributing. There's imports and exports taking place, and that's pretty much under control. So it's a growing market. That market is a growing market by about 10% per year. Just before about 2 years, but it's about 20 million tons grown from 2 years. So it's about 5% per year. In 2 years back, it was 180,000 million tons. So that market is the big problem. 93 or 8, I think 98% is produced currently through dirty processes. And that is a problem. And the world wants to see that changed. So deploying this kind of technology, deploying this opportunity, means that you're going to have a market. Your market is to grow into the existing 200 million tons that grows by 5 to 10% anyway per year. There is a cracking device already available that they use to split the nitrogen and the hydrogen again. So that technology is available, accessible, and makes sense financially. They are now looking at ships to power them with ammonia, and then also the carrying capability of hydrogen, and the world is importing hydrogen from various places, but they transport it in the form of ammonia. There's a big importer, Japan. Germany is also soon to be a big importer of ammonia. And yes, the Russians are now causing a lot of problems with the price and with the production of ammonia, because if you take into account the Russians, the Indians, and the Chinese currently produce almost 50% of the ammonia of the world today, as it stands. And with this war, there's a big shortage, so the price has risen in a big way. Very interesting thing that I learned in my investigations of the product was that there's an internal combustion jet engine where they use ammonia, but they split it out. They split the hydrogen out, and then they dilute it a bit for its calorific value, and then they use that but you have a zero emission. And a very interesting thing that I read, that was not part of the presentation, it was after the presentation that I read it, was that the Euro 7 has gone ahead and they want 100% clean cars now going forward. So zero emission is going to be pushed through, and that's going to have a big impact on batteries, on the way forward in terms of what the motor industry is going to do. So I can see that ammonia can be easily transported to what we typically now see as a petrol garage, that the cracking device is used to take the hydrogen out and then for fuel cells. So if you look at, and I liked that picture about the cattle, the horses running around in the cities. We have another product that we've developed, a partner of me, and we wanted to roll that out, and it's a battle to get it in. The business is Futron. It's a transportation system that runs overhead rail with solar. We are in China. We've got a factory there, but we get blocked by all these illnesses that's running around. But then I also got hold of those pictures of the horses and the things with that. But I really think the industry is going to change in the vehicle environment as well. And ammonia, again, is going to play a pivotal role in that. So this is what this piece of land looked like that we acquired. It is about 280 hectares. You'll see that we have the top light blue area there. We've got a fountain there where currently Nestle is bottling water. So that piece of land there would all be agrivoltaic, of the last picture that I've shown you, that will be installed there. And then you have these green areas. We will have trees that we plant. We've identified a specific tree, and sheep farming there. The brown areas is housing, and the whole area will be powered by this agrivoltaic area, and we'll have a community development there where the community participate and where there's housing for the community as such. The housing will also allow for others to come and live in the area, but it will always be preferential to the people working in the area, and that's part of that. So But I wanted to show you this picture because D, you'll see there's a very small purple area there. That's the only area that we need to produce 2,000 tons of ammonia per year from a 4.5 hectare power plant. So the rest goes into the facility as such. So that is how we see the future and where we want to do our property development, how we want to do it, how we want to contribute to the energy part of it. It would make a lot of sense if it's an affordable thing that to put nuclear power in and to support it with that as a base power, maybe produce more ammonia, better income stream for the community. We are not there. We don't know what that technology can do for us, and we would love to investigate that further as we go ahead. So I'd like to close with what Max Planck said, and that is, I think, the important thing. We need to consider every step carefully in advance, but then if you believe you can take responsibility for it, nothing must stop you. Now, responsibility, I use that word to define a man. I always say to my kids, what is one word that can define a man? And I think responsibility. You need to be able to take responsibility. We are happy to take responsibility for this project that we have in mind, and not in mind only. We've signed all the agreements to go ahead with it, and a few others, and we look forward to that, and hope next time if we have this type of discussion around it, we'll go show you the first one. But Chris, you really surprised us, and I'd really like to take hands with you and share some notes, but thank you very much for that. Thank you.